So what we had seen in the last session was the topics related to module 1. We had looked at the communications module and different types of the communication networks, what entity, medium, protocol, the types of communication media, analog and digital. We looked a little bit about LAN, WAN, and MAN and the difference between them in terms of geography. Then we saw all about topologies. Topologies, we saw 6 types of topologies: mesh topology, this one, star topology, tree topology, bus, and ring, and also hybrid, which is a mix of any of the topologies. And then last, we saw protocol architectures. Protocol architectures, we saw 2 protocols: OSI model layer and TCP/IP layer. So that was what we did in the previous class. In this class, what we're going to do is, so from the same module 1, we're going to solve some questions. Let's begin. Okay. So this module has a lot of theoretical questions. There are also a few numerical type questions, but let us see some questions. Okay. Assume 6 devices are arranged in a mesh topology. How many cables are needed and how many ports are needed for each device? So let's go back to the previous session's notes. We had seen in a mesh topology, if you do the permutation and see how many total number of links there are, you'll find there is n into n minus 1 by 2. We can directly use this formula. So if you want to draw it again, you can, but let's just quickly use the formula. So that's how many cables. How many ports do we need? So normally when you have uh, three, let's say three um, devices, right? This one in a mesh topology, this device needs to be connected to this one and the second one, right? So it needs one port for here, and it needs one port for this to run on, and it needs one port for this to run. So actually, the number of ports required in each device is based on how many networks there are. So if there was just 2 devices, they only needed this device needs only one port, and that one port will connect to the one port here. But here, since you have 2 links, you have 2 ports. So in general, ports, well, no, let me write it now clearly. Okay, so cables, number of cables or links or whatever is always going to be n into n minus 1 by 2. And number of ports is always going to be 1 minus from the whole ports. So n minus 1. So you saw when we had 2, we just needed one port. When you had 3, you needed 2 ports. So it's always n minus 1. So what will the answer for this be? If you have 6, right? So C is equal to what? 6 into 5 divided by 2. That's 30 divided by 2, which is equal to 15. So you need 15 cables in this topology. Number of ports. Ports, we have total 6 devices. N minus 1, 5. So number of ports is 5. That's it. That's all that's there in this question. Okay, let's move on. Question 2. So these are again textbook questions. So we're given for each of the following four networks, discuss the consequence if a connection fails. So you're given four networks and it's in different topology. You have mesh, star, bus, and ring. And what would happen if one of the connection fails? Not a device, connection. So if these both are gone down and this connection fails, these will still work and this will be gone. So that's how we'll have to look at for each of the questions. Okay, so first one, five devices arranged in mesh topology. We know that in mesh topology, each device is connected to each device directly. There's no bus or hub or anything, right? If one of these connections goes down, what will happen? The device, if this connection goes down, what will happen? Oh, okay. So these both devices, let's name it A and B. A and B will not be able to communicate to each other, but A will be able to communicate with C, and B will still be able to communicate. So in mesh, it's simply so one connection goes, other connections will still work. Okay. Now let's see the second part. If we have five devices arranged in a star topology. So we know star topology means that there's a center. There's a hub, and then the devices are connected from all the devices are connected to that hub. So it's given what if one of these connections fail? And the question says not counting the hub. So the hub is awake, and let's say this connection goes. Now what happens? The device that was connected using that connection cannot communicate anymore. But the rest of these devices are still connected in this network. So that is the answer. So the rest of the devices will still be able to communicate, but the one that got disconnected, so one device will not. So which device is that? The one that was connected to the disconnected connection. Okay, five devices connected in a bus topology. That's right here. You have a bus, you have your devices connected like this. Now, what would happen if a connection fails in a bus topology? So let's say, first case, let's say the bus fails. So the bus goes. So now is anybody connected to anything? No, everything has been disconnected. So if the bus fails, you lose all connection in the net. But let's say one of these connections go instead. Okay. If one of these connections go, only that device is disconnected from the rest of the network. The rest of the network is intact. So if the bus fails, there is no connection. Otherwise, only one device fails. Right? If the bus goes, nobody can communicate to each other. But if one of these small connections go, only that specific device will be affected. The rest of the devices will be able to communicate to each other. Okay, last one, the ring topology. So when you're in a ring, each one is connected to that one node that is nearest. This forms a loop. Now, what would happen if a ring topology some connection fails? So Let's say that one goes. Are they still able to communicate with each other? Well, yeah. So this node communications can still happen between these two, between these two, between these two. But this is what has become disabled, right? So what happens if in a ring topology? So just it affects only the disabled. It affects only the disabled link, or only the devices on the disabled link, right? Because the rest of the network is still able to communicate. So that was this question. So it is so depending on which network, which link you take, you can check whether it will affect anything or whether it will not affect anything, and everybody will be able to communicate or not. Okay, let's move on. Question 3. So now the question. Now we're going to give two. We're going to give some drawing type questions. So and since he's it says draw a hybrid topology with a star background and three ring. So you have a star and you have three rings. So since this is from the textbook, I'm just going to show you the diagram, and then we can actually look into the diagram and see whether it matches the question. So this is a diagram that's given in the textbook. So we're asked for a star backbone and three ring networks. How would you do this? So as you can see here in this diagram, you have one ring network here, another one here, another one here, right? And how are these three ring networks connected? They're connected via a hub, and hub is something that you see in star. So you have a hub. Let me remove all my markings. You have a hub, and you have three rings that are connected to each other via that hub. And inside each ring, there are its own stations and repeaters. But what if it was said instead of star background, it was said bus back? Then it would look like you have rings and you have a bus, and each of those rings are connected to that bus, right? Uh, what if they said if you have so let's write if you have star topologies in a ring backbone, what will this look like? So you'll have star topology, so you'll have hub. Let's give it two nodes. You have another hub, two nodes, and how will these three hubs be connected to each other in a ring? So that is what a star topology in a ring backbone would look like. So let's there's another drawing question. Let's try and work that one out. Oh, draw a hybrid topology with a ring backbone and two bus networks. So what will this look like? You'll have bus, and the buses themselves need to be connected via ring. So you'll have a direct between bus to bus because ring means each one is connected as if it's a loop. And if there are only 2 points, then you get a thing like this, a straight line. So let's look at the diagram that's given in our textbook. Yeah. So you have this area of a bus. So you have see here's the bus and the two stations connected to it. Here you have another bus over here. So you have the bus and two stations connected to it. And oh, so what they've done here is see how they've made a little ring here. This is to symbolize. So instead of having just two spots, they've made a loop like that here. But the repeaters are they've shown only at the intersection, and the rest is the loop. This is another question. So basically, when you have drawing questions that ask hybrid networks, find what the main thing they're asking. Like for example, here it is ring networks, and what is the backbone they're asking. So here it was star, or here it was star in a ring backbone. So whatever the main thing is, not the backbone, the other one, you'll have to draw many of those, and then you will connect those subcomponents by the backbone. So here the backbone was ring, so we connected these two in a ring. Here also it was ring. Here it was star, so you had to connect them in a star fashion. So the three subsections, this one and the other thing, you had to connect them to each other in as if connect those subcomponents as a star. Star means you have to use hub. Right. Okay, so this is another type of question. Drawing. Okay, let's move on. So the next type of question we're going to see is going to be layering, match the layer type of question. This is actually a very important question even when I was studying OSI models or the computer networks. I had these type of questions. So let me paste what a type of question could be. Yeah. So what they'll do is they'll say match one of these. They'll give you the function and they'll say which layer of the OSI model does this. So here you can see they said route determination, flow control, interface to transmission. They're given some functions. And I said which layer of the OSI model will do this. And this is a very important question type that comes often that shows up often in your tests. So the first thing is you list down what are the OSI layers. So I'm just going to list it down here. What are the OSI layers that we have learned? We have learned phys. So let's start from application. So remember the mnemonic. All people seem to need data processing. So application, presentation, session, transport, data link, and physical. Physical. Now, which one would you put for these specific functions? Okay, so first one, let's do them one by one. First one, root determination. Which one do you think? Which layer do you think is responsible for root determination? So if you had watched, I mean, or if you had seen our lectures, we talked about routing protocols. What is routing protocols? Things like OS, OSPRF, Open Shortest Path algorithm. We had seen all the directors algorithm, all the shortest path algorithms, Bellman faults. All these things were happening in the network layer. Oh, I did not mention it. All people seem to need network. All of those things happening with related to routing happens in the network layer. So this is clearly network. Okay, let's move on. Flow control. Which one would be flow control? Now, flow control, we have not reached the sixth module yet. Um, but flow control basically means you have messages going from one place to another, right? So they're in a channel. How are they sending that link? So in transport layer, what you will see, or maybe if you're watching the recording, you can watch that lesson first. Transport layer has UDP and TCP connections. So UDP and TCP are two protocols that have different ways of controlling how many messages are flowing in the link. What is UDP and TCP the only way to connect to control flow? The answer is actually no, because when we saw the data link layer, we also saw that the way the data is being transferred, we saw the different types of connections. We saw how things can be, waiting at a router and then being forwarded later. So actually, the data link layer also controls flow control. So what is the answer? So since they've allowed us to match more than one layer, we do not have to stick to one. So flow control is going to be the data link layer for T and also transport T. And we'll be doing some of sessions on transport, and we'll finish that module also. So okay, interface to transmission media. So somewhere in this OSI model, you have, we saw in the communication world, you have a device and you have a connection. Somewhere that gets from this device to this connection. It provides an interface to the transmission media. So what is this device actually? It's the components, the hardware. It is the physical things. So that is actually your answer. So physically, the physical layer is what the last hardware. Let me just write HW, the hardware, where it meets media, right? And then the data link layer onwards, you've already reached the connection. You're already talking about forwarding things like that. So that last interface between the hardware and the transmission media, that happens in the physical. So this is the physical layer. Okay, access to end user. So at the same way, so you have another device here. Let's say this is a monitor. So for one monitor, it transferred to the other monitor. And the end user who's looking onto the screen, he's going to be seeing the application, right? So he's going to be seeing the whatever's shown. But what is the last layer before he sees what is being shown in the screen? It is the application layer. Physical layer is the first layer that's an interface between the device and the connection. Application is an interface between the connection and the device. Back. So the answer here is application. Okay, let's do some more of the same type since we're doing this. Mm, Match the following to one or more layers of the OSI. Okay, same type of question. Reliable process to process delivery. Where does that happen? So have we talked about reliability before? So the answer for this is actually transport. And I'll tell you why. Because transport, again, you have. So let me just give you a brief idea of TCP UDP. You have TCP and you have UDP. TCP does handshake. I'm just going to write SH. And UDP does not. No. And this is basically all that you have to know. If it does a handshake, that means it's a very secure protocol. You have two nodes, they send acknowledgements to each other, they have proper connection, then only data is sent. But UDP does not have handshake, it's immediate. So you have one node needs to broadcast something to other nodes. It doesn't check for proper connection, I think it just sends. Right? But you'll be wondering why, what is the use of sending something if it's not reliable? The thing is that UDP takes a lot of time to set up the connections and perform the handshake. So that's why people prefer UDP when it's all about speed. For example, when it's like video calling. So video calling, it's all about that latency and having a proper uh, being in sync with everybody. So in cases where speed is more important, UDP is used in those cases. So process to process reliability, that's always transport. Okay, next. Route selection. Again, anything with route, anything with routing, we had route determination. It's always network. Okay, defines frames. Where did we see frames? When you see the word frames, you need to remember that it's happening in the data link layer. If you see the word hops, that's something that happens in the physical layer. But frames is how we see data in data link layer. Yeah. Let's next one. Provides user services such as email and transfer. Immediately you should know that it's application layer because it's an application layer that we have all HTML, SMTP, all those kind of protocols. Right? It's the last thing that before the user sees the information. Okay. Transmission of bit stream across a physical medium. Physical, you have the word physical. It's a physical layer. Okay. Let's do some more of this type. Hmm. Master following again same thing. Communicates directly with the user's application. You see the word application. A. You write that a little better. Oops. Error connection and retransmission. So we have seen error connection in many places actually. We saw it in data link layer. What is the error correction mechanism? We saw CRC, we saw checksum, we saw all those kind of corrections. So for this, error correction is going to be data link layer. But is that the only place where error correction can happen? And if you remember, we saw in the previous question reliability. Means reliability is always related to the transport layer. And actually, error correction and retransmission also includes the transport layer, right? Okay, let's move on. Mechanical, electrical, functional. When you see mechanical, physical needs to be physical. Physical is the only thing that can give inference, can give interface between physical objects and the network. Responsibility for carrying frames. Here again, we saw the word frames. Immediately you can put that is meant to be the data link layer. Okay, we have time for one more. Format and code conversions. Oh, code conversions. Which layer does code conversions? You'd be tempted to put application because it's code, but the keyword is actually in formatting. So code conversion services when you're having something written in some code and you want to format it into another code, that is going to be presentation layer, because that is what the layer does. Before the application does, it is responsible for formatting and not just the code. The application layer is for those application layer protocols like HTML for websites. So this is actually going to be presentation. P is physical. Let me write PR as, so let me type it. I think might be better. PR. So APR establishes, manages, and terminates sessions. Is there in the question in the word session, because it says sessions. Okay, ensures reliable transmission of data. Reliability, error correction. Whenever you say this, it's always data and transport. Okay, log in and log out. So what is logging in and logging out? You have a portal. You're going, putting your credentials, logging in, and then whatever you're doing is being saved. You have cookies or whatever that's being saved, and then you leave. What is this entire thing called? This is what is a session. Session will include all the activities that you did, the timestamps, everything together. So logging in and logging out is controlled by session. Since we're writing everything, let me write this as presentation. Okay, final one. Provides independence from differences in data representation. So what does it mean? Provides independence from difference in data representation. That means data representation does not make any difference. Why does it not make any difference? Why does data representation types not make a difference? Because there's easy way to convert between data representation types. Conversion happens only in the presentation layer, right? So that is why this is also presentation. Okay, so we can stop here. We can do some more similar types of matching OSI layer questions in next class. Today we saw this type of question where they ask you to identify which layer it is. We saw if they ask you to draw a hybrid type of network, how it is. We saw these type of questions where they ask you theoretical or like scenario based. This could be converted into a scenario. So let's say many academic blocks are connected to one central block. If one wire fails, how will the blocks be able to communicate with each other? So this can be converted into a scenario based question also. And finally, these are the small numerical type questions. These are just a simple formula. Even if you don't remember this formula, you can always draw something and draw a network and count the number of ports or the number of connections. Okay, uh, that's all for this session.